In some cases, when you're evaluating a linear system of equations in three variables, you end up not getting all of the variables with coefficients in some of the equations. What I mean is, for example, if you have 3x plus y is equal to 5 as the first equation, 3y minus z is equal to 2 as the second equation, and then we get x plus z is equal to 5 as the third equation. I want you to note that the first equation doesn't have a z term, the second equation doesn't have an x term, and the third equation doesn't have a y term. Now, the way to rewrite this so that it makes more sense is to kind of write it in a sort of column way. So the first equation, you want to write 3x plus y, and then leave a space where the z would be, and then equals 5. And then for the second equation, you want to leave a space where the x would be, and then write 3y minus z is equal to 2. And then the third equation, you want to leave a space where the y would be. So x plus z is equal to 5. Now, if you feel so inclined, you can, put 0 times z here, 0 times x here, and, 0 times y here. But, it's not that necessary. It depends on how you feel about how you need to organize your thoughts in a certain way. So now that we've rewritten our equations so that they're a little bit more organized, let's label them 1, 2, and 3. So now that we've labeled our equations, the goal is to find two pairs of equations and to cancel out the same variable for each. And the point of that is so that we can end up having a linear system with two equations and two variables instead of three equations and three variables. Now, I want you to note that the first equation doesn't have a z term at all. It's just 3x plus y is equal to 5. And if we add the second and third equations together, then the negative z and the positive z are going to cancel out when we add them together. So combining equations 2 and 3 will give us an equation that when we consider it with equation 1 will be a linear system in two variables. So let's add equations 2 and 3 so we can cancel out the z first. So let's just rewrite equation 2. That's 3y minus z is equal to 2. And then equation 3 is x plus z is equal to 5. So now x, there's only one term. Y, there's only that 3y. The z's cancel out as we wanted. And then 5 plus 2, we get 7 here. So we have equation 4. And if we consider that with equation 1, which is 3x plus y is equal to 5, then this creates a linear system with two equations and two variables, which we already know how to solve. So let's take a look at these two. 3x plus y is equal to 5. Now that we have these two, the goal is to cancel out the coefficients in one variable. So let's say I want to get rid of the x. So the way I can get rid of the x is if I multiply this top equation by negative 3. Because note that if I do that, then the coefficient up here for the x is going to be negative 3, which when we add it to the second equation, it's going to completely cancel out the x variable. So let's do that. Let's multiply the top equation by negative 3. So get negative 3x minus 9y is equal to negative 21, and then we'll leave the bottom equation alone. So canceling out, the negative 3x and 3x are going to give us 0, which we don't need to write down. Then here we get negative 8y is equal to negative 16. And so dividing both sides by negative 8, we get y is equal to 2. So that was our y. And now we can use our y to find another variable. In particular, we can plug it into equations 4 or 1, either of these, to find x. So plug y equals 2 into equations 1 or 4 to find x. So I'm going to plug it into equation 4. So now we get x plus 3y is equal to 7, which is equation 4. And plugging in, we get x plus 3 times 2 is equal to 7. Excuse me. Which means that x is equal to 7 minus 6, which is just 1. So now we have two of them. So now we can plug in x is equal to 1 and y is equal to 2 into any of the original three equations. Now remember that we're trying to solve for z, right? So the only equations that we could put it in, ideally, are the bottom two, because those have z's. So from here, we just pick whichever one looks easiest. And for me, I'm guessing the last one, equation 3, is probably the nicest one. So let's plug it in. Plug x equals 1 into equation 3. So we end up getting x plus z is equal to 5. That's what equation 3 says. And since we know x, we get 1 plus z is equal to 5. And then subtracting a 1 from each side, z is equal to 4. So now we have all of our three solutions, and we can finally write down the conclusion, which is the solution of the system, or the solution to the system, is the ordered pair x comma y comma z. So x is 1, comma y, which is 2, comma z, which is 4. So that's the solution to the system.